In this tutorial, we will briefly introduce waiting lines. Waiting lines are also known as queues. The characteristics of waiting lines are as follows. 1. Source population. 2. Number of servers, also known as channels. 3. Number of lines. 4. Arrival pattern. 5. Number of phases. 6. Queue discipline. 7. Service time distribution. 8. What happens at exit. Each of these is discussed in more detail. An important consideration is the size of the population that generates the queue. This is expressed as either an infinite or finite-sized population. While no population is truly infinite, we call it an infinite population when the number of potential customers is so great that an arrival does not change the probability of another arrival. Gas stations and grocery stores typically have infinite populations. A finite population is small enough that an arrival likely changes the probability of another arrival. For example, calls to a repair department to repair a copier in an office building. The capacity of a queuing system is a function, in part, of how many servers there are. Typically, these are classified as either single server or multi-server. Of course, a single server has a single line. When there are multiple servers, there can be a single line or multiple lines. At your grocery store, each server has a dedicated line. This can lead to customers switching lines to try to be served faster. At your post office, most likely there is one line regardless of how many servers there are. Each time a server is open, the next customer proceeds to that server. This type of line is also known as a serpentine line. It is perceived as fair since everyone waits in the same line. However, it precludes the ability to have a separate line for different functions, such as an express line for 10 items or less at the grocery store. Arrivals are variable and are often seen as random events. However, they can be described using statistical distributions like the Poisson distribution. At the grocery store, you wait in one line and all of your service is handled by a single service provider. This is a single-phase system. In renewing your driver's license, you wait to submit a form, wait again to have your picture taken, and wait again to pick up the finished license. Each of these waits has its own line and server. This would be a multi-phase system. Queuing discipline refers to how customers are selected from the line for processing. When people are the customers, the overall majority of the time, the first person in the line is the first person served. People see this as the fairest approach. However, restaurants may select people in the back of the line if they have a reservation. Also, a hospital emergency room will select people based on how urgent they need care rather than arrival order. When objects are involved, rather than people, a wider variety of selection models might be used as perceived fairness is not an issue. Like arrival, service times are often described using a statistical distribution such as the negative exponential distribution. However, service time could also be fixed. For example, the time to ride an attraction at an amusement park would always be the same. Another issue is what happens when a customer exits the system. A copier that has been repaired could immediately fail again, so it immediately re-enters the population of possible copiers to be repaired. I got a haircut this morning. I will need another one in about a month. So, I will re-enter the population of possible customers for my barber shop, but only after a delay. A copier waiting to be scrapped will never re-enter the population once it has been scrapped. Lambda is the statistical parameter of the customer arrival rate, and mu is the statistical parameter of the service rate per server. When there are multiple servers, we assume the same rate for all of them. Note that 1 divided by mu is the service time. L sub q is the average number of customers waiting, and L sub s is the average number of customers in the system. Note that L sub s is always larger than L sub q. L sub max is the maximum number expected in the wait line. Likewise, W sub q is the average wait time, and W sub s is the average system time. W sub s is always larger than W sub q. R is the average number of customers being served. Rho is the system utilization. P sub n is the probability of n units in the system. So, P sub 0 is the probability of no units in the system. M is the number of servers. There are many different queuing models and some are quite complex. For these tutorials, we will limit ourselves to 3 of the simpler models. 1. Single server with exponential service. This is far and away the most commonly covered waiting line model in operations management. It is, in fact, the only one I cover when I teach operations management. 2. Single server with constant service time. This would model an amusement park ride. 3. Multiple servers, such as a grocery store. There are separate tutorials on each of these so you can easily select the ones covered in your course. If this video helped you working operations management problems, please consider liking the video and subscribing to the channel.